Example 5 and 6 are very similar because they both have straight lines and parabolas, and we are again required to know what the intersection points are so that we can figure out the area between the two curves. And in order to find the intersection points in this problem, we have to set the f of x to be equal to the g of x. So in other terms, we have to set the equation x squared minus 4 to equal 4x plus 8. And to solve that, we need to get everyone to one side. So that's what we have right now when I move the 4x and the 8 across. And so now I'm required to pretty much factor the problem by looking for two numbers that multiply to negative 12, but when I add the numbers, I get negative 4. And I'm thinking maybe negative 6 and positive 2. When you multiply them, you get negative 12. When you add them, you get negative 4. So x minus 6 and then x plus 2 are the solutions, which means that my first number should be a 6, my second number should be a negative 2. So it makes sense for the negative 2 to go first on the graph, so that's the left one, and it makes sense for the 6 to go on the right of the graph, so that's the last one. And so the region that we care about is the region surrounded by the parabola and the line and those two values. So basically this region that I'm highlighting in yellow. So that's the region that we care about in this problem, and we want the area. So that means we're going to do some kind of an integral. So the area is going to be the starting point of the integral, negative 2, and the endpoint, which is 6. And next, what we have to do is put the top function minus the bottom function. So forget everything that's going on here, forget everything that's going on there. On the region that we care about, what is the top function? What is the bottom function? On the region we care about, the top is the straight line, which is in this problem, the g of x function. So it's going to go first, its equation goes first, minus the bottom, which is parabola, and that's the f of x. So it's going to go next. And we integrate with respect to x. So the integral is going to go from negative 2 all the way to 6. The function g of x, which is 4x plus 8, minus the function g of x. Minus the function f of x. And the f of x in this problem is x squared minus 4. And keep in mind, I'm putting parentheses everywhere because I want to make sure that my minuses distribute correctly. So this is the integral from negative 2 to 6, and then 4x plus 8 minus x squared plus 4 dx. Let's combine like terms real quick and then integrate. So 4x doesn't have any friends, leave it. The 8 and the 4 will be 12, and then the x squared at the end. And so the antiderivative is going to be 4x squared over 2 plus 12x minus x cubed over 3. And we're integrating between negative 2 and 6. So let's plug in the upper bound, plug in the lower bound, and see what the final answer looks like. So in this case, the upper bound gives us 72, and the lower bound gives us negative 40 divided by 3, and the total will be 256 divided by 3. That's basically the area that we have highlighted in yellow. So I think it's very straightforward, don't you think?